A man pulls a sledge of mass 25 kg across level ground with the horizontal force of 60 Newton. A constant force of friction 20 Newton acts on sledge. What is the acceleration of sledge? So let's calculate the information from it. So we have first information regarding mass. You can see we are like the mass is 20 kg. Okay, 1 second, I'm gonna underline it because okay, then a horizontal force. Okay, suppose we have a sledge like this, a man is pulling it like we are assuming that the sledge is pulled in this direction, and this horizontal force is given as 60 Newton. Here is force of 60 Newton. Okay, I'm gonna put 60 over here. Okay, 60 Newton is working here. Okay, 60 Newton force is acting on it. A constant friction force of 20 Newton. Okay, 20 Newton is acting in this direction. Okay, I'm gonna put it like this. Okay, 20 Newton is acting in this direction. What is the acceleration? Okay, so resultant force is actually 60 force is applied force, and there is a 20 Newton which is resultant which is friction force. So we are left with 40 Newtons, which is our resultant force. Okay, by Newton's second law we know that F equals ma, which is equal to 40 Newtons, and mass is given, which is 25 kg. So now if you move 40 to the other side, it would be 20. I'm gonna divide it both sides, so it would be 1.5, 1.6. Okay, the answer is approximately 1.6. So here is our correct answer. So this is our correct option, and rest of the options are incorrect. So it's incorrect, incorrect, incorrect. In question number 2, it says a car is moving. A car moves in a circle at a constant speed. What is the direction of resultant force acting on it? So a car is moving along. You can see there is a dotted circle like this. You can see a dotted circle as well. Here is a dotted circle. Let me draw a complete circle for it. Okay. Let's assume like this. Okay. there is a center of circle as well. Okay, let's assume this is the circle. Now the force which actually is responsible for its motion along the circle is centripetal force. So centripetal force is always directed towards the center. So this centripetal force is directed towards the center, which is responsible for its motion along the circular path. So I think so. Option is already marked. You can match. Okay, let's move to next one. It is something misprinted, like number is misprinted. 4 forces acts at a point. Like suppose you have a point, this is the point. Okay, this is the point, and we have 4 forces acting on it. Like this force is upward, this force is downward. You can say weight is 2 newtons and the normal force is 2 newtons. So unfortunate. Okay, now it is little placed. Okay, so you can say 2 newton is acting in upward direction and 2 newton is acting in downward direction. So these forces are balanced. Okay, so these two are not going to make any change, so let's cross them. These two forces are balanced. Okay, so now we have 8 newton along this direction and 4 newton is along this direction. So we can just add them. Like if there is a force, we can use direction as well. So we have 4 newton which is like in this direction. So our resultant force is 4 newton. So that's cross, and we have only this one. Okay, in number 4 it states when a car turns a corner at speed, it risks toppling over. 2 factors affecting the stability of the car are height from the center of the mass and distance between the front wheels. Okay, so one thing, let's discuss something about the stability. So we know that suppose it's an object. So if center of mass is lower, means it is near to the base, then the object would be more stable. If the base area is large, then stability would be high. So we know that 2 factors. First is large base area and lower center of mass. So let's see what actually it states. Yes. Okay, which factors make the car most stable? A is center of mass is high. Okay, that's incorrect. Center of my mass cannot be high, it should be lower. It means this whole thing is incorrect, because one element incorrect, rest of the things are already incorrect. Now center of mass is high, it means again this one is incorrect. Center of mass cannot be high. Large base area is acceptable, but overall it would be incorrect. Okay, number C, center of mass is low, that's fine, and distance between the front wheels means distance, small distance means small base area, so that factor is incorrect. That is correct. Overall it is incorrect. So it means we are left with only one option that would be most probably correct. Center of mass would be lower and larger, so overall we have this option. Number 5, a metal ball of mass 0.3 kg and weight, it means you just multiplied 0.3 multiplied by 10 will give you 3 newtons. We know the formula of weight, W equals mg. Okay, like, I don't know what happened with my okay, weight is W equals mg. You multiplied 0.30 with 10, you will get this weight is held so that it is below the surface of the oil, below the surface of oil. It experiences an upward force of 0.30 newton. Okay, it means here is an oil and there is an upward force. Okay, when the ball is released, what is its acceleration? Okay, let's calculate this. What is resultant force? I'm gonna put it at like this. Resultant force, which is equal to 3 newton is in downward direction and 0.3 is in upward direction, so we have 2.7, which is our resultant force, and we know that we can write resultant force as F equals m times A. So m is 0.3, A equals 2.7, so A would be equal to 2.7 divided by 0.3, so A would be equal to, if you divide you will get 9, so our correct option is 9, and it means these three are incorrect and we have only one which is the correct one, like this. Okay, in number 6 it says the car oh my god, the earth travels in a circular orbit around the sun. This is earth and here is the sun. Earth is actually orbiting around the sun in a circular path like this, and this motion is called centripetal circular motion, and the force is the force which is responsible for this motion is called centripetal force. Which arrows shows the direction of acceleration of the earth and direction of the velocity of the earth? So whenever the object would be moving along a circular path, at each point the direction of velocity would be tangent to the circle, like this. At this point it would be like this. At this point the direction of this would be like this. Always perpendicular, always perpendicular. Oh, not perpendicular, tangent, sorry, the wrong term I used. Okay, always tangent. So at this point it would be tangent like this, but this is the direction of the velocity. So I think we are matching with Q. So Q is our correct option for velocity. So Q is correct here and Q is correct here. Okay, now the second thing is direction of acceleration. Force is actually always acting in inward direction. The direction of force is towards the center, which is centripetal force. At each point the force would be towards center like this. At this point the force would be towards the center like this. At this point it would be towards the center. And the direction of force and direction of acceleration is always same. So it means correct option is somewhere here. Okay, R. R is the correct option. So the direction for acceleration we have R somewhere here. So overall this option is incorrect. This option is incorrect because none of them is matching. This option is incorrect and this option is correct. Okay. In question number 7, it states which object has the largest resultant force. Now you can see it's a parallel case. Parallel anti-parallel forces are acting on all of them. So let's add them. These two are parallel and in same direction, so we will add them and it would become 10 plus 10 20 and 30 is opposite in direction. So 30 minus 20 is 10. So for this case our resultant force is 10. And in this case, which is the second case, 10 Newton plus 10 Newton both are in same direction, so we will add them together, so it would become 20, and this 10 is in opposite direction, so 20 minus 10 is 10. So our correct option for this one, the resultant force is 10 newtons. Okay. In this case, you can see Five Newton and 5 Newton, which is 10 Newton in this direction and 30 Newton is in this direction. So 30 minus 10 is 20. So in this case we have 20 Newton as a force. Okay, in case of D, you can see all three forces are acting in the same direction, 5 plus 5 plus 5. So resultant is 15. So now you can compare them, which one has the largest resultant force. So 10 and 10 both are incorrect because both are same. 15 is also not correct because 20 is the largest number, so 20 Newton is the largest force acting on it. Okay, in question number 8 it states, in which example does the friction force and the direction of motion of an object are acting in the same direction? Like direction of friction and direction of motion are always opposite, but there is a special case in which both are in same direction. So oh, this is eighth one. On a suitcase accelerating on a conveyor belt, on a skies of a skier accelerating downhill on a smooth snow, both are like in these two cases the direction of friction and motion are always opposite. On tires of brake, that is always opposite. So in my opinion, I think we have this option. In case of 9, the diagram represents the moon in its orbit around the earth. Which arrow represents the direction of resultant force acting on the moon at the instant shown? Okay, this is the direction of motion of like the moon, and the moon is under the influence of centripetal force. So I think the resultant force would be like this. So centripetal force is always acting towards the center. Okay, so I think this is the correct option. You can match it. Like centripetal force is inward in direction. This is the centripetal force, and this is one second. This is centripetal force, and here is a centrifugal force. Centripetal force is inward direction, centrifugal force is in this direction. This is the direction of velocity. Like the C is the direction of velocity, B would be some, I don't know what is that.